Bismillahirrahmanirrahim. Now our topic is Bayes' theorem. So first we'll go through the definition and then we will try to understand what Bayes' theorem is and where and how it is applied using some examples. So Bayes' theorem is used to find probability of A given B when the available information is not immediately compatible with that required to apply the definition of conditional probability. The Bayes' theorem describes the probability of an event based on the prior knowledge of the conditions that might be related to the event. So let's look at an example. Consider two bowls X and Y filled with orange and blue balls. We have got a bowl X over here, it has got orange and blue balls, and there is a bowl Y which has also got orange and blue balls. The number of orange and blue balls in each bowl is known. If you pick a ball from bowl X, you can tell the probability of picking an orange ball. Since there are 11 balls in the bowl X, in this bowl we have got 11 balls and 3 of those are orange balls. You can see the 1, 2 and 3. The probability to pick an orange ball is 3 divided by 11. But what happens if you pick a ball from any of the two bowls? So you don't know if you have picked a ball, orange ball, from which bowl? From bowl X or bowl Y? Can you tell the probability which bowl the orange ball was picked from? So Bayes' theorem is used to solve such problems. Bayes' theorem gives you the actual probability of an event given information about tests. Events are different from tests. For example, there is a lab test for liver disease, but that is separate from the event of actually having liver disease. Tests are flawed, means that you may have error in the test result. Just because you have a positive test result does not mean you actually have the disease, because the test result may have some error. Lab tests may have a high false positive rate. Rare events tend to have higher false positive rates than more common events. For example, spam filtering can have high false positive rates because the number of spam emails is rare, and to have the normal emails is more common. Bayes' theorem takes the test results and calculates your real probability that the test has identified the event. So Bayes' formula is like this: probability of A given B is equal to probability of B given A multiplied by probability of A divided by probability of B. So now let's have a look at Bayes' example. It will also tell us how to use Bayes' theorem, where and how to use Bayes' theorem. Suppose you are finding out a patient's probability of having liver disease if he is an alcoholic. So what we are assuming is that there is a relationship between liver disease and being alcoholic. Being an alcoholic is the test for liver disease. Here, what is test? Being an alcoholic. A represents the event. Patient has liver disease. So what the event A is? Patient has liver disease. That is event A. Past data tells that 10% of patients have liver disease. So altogether you have got the patients who have come to for the test, 10% have liver disease. B represents the test that patient is an alcoholic. So being an alcoholic is represented by B, event B. 5% of the patients are alcoholics. So there are 10% patients who have got liver disease and 5% patients who are alcoholics. Among those patients diagnosed with liver disease, 7% are alcoholics. So probability of A is 0.1 because we know that it is 10%. Patients has liver are 10%. So P of A is equal to 0.1. And probability of B is 0.05. Patient is an alcoholic is 5%. So that is P of B is equal to 0.05. And this information over here, the patients diagnosed with liver disease. So here event B given A. What is event B? Event B is patients are alcoholic, and it depends whether the patient is has got liver disease or not. So that is given. This is the percentage or the probability B given A. B is the event having being alcoholic, and A is being having liver disease. So probability of A given B, which is that you are alcoholic, you have got liver disease, given that you are alcoholic, is what? 0.1 multiplied by 0.07 divided by 0.05. We have just plugged in the values in this formula. Probability of B given A multiplied by probability of A divided by probability of B. So here what we got is 0.14. So if the patient is an alcoholic, their chances of having liver disease is 14%. The chances of having liver disease is 10%, but if the patient is alcoholic too, then the probability increases to 14%. There is another example. In a particular pain clinic, 10% of patients are prescribed narcotic pain killers. Overall, 5% of the clinic's patients are addicted to narcotics. Out of all the people prescribed pain pills, 8% are addicts. If a patient is an addict, what is the probability that they will be prescribed pain pills? So we have to calculate the probability of prescribing narcotic painkiller given that the patient is already a narcotic addict. Let A be the event a patient is prescribed the narcotic painkiller. So that is given over here, that is 10%. 10% of patients are prescribed narcotic painkillers. Let B be the event the patient is narcotic addict. So it is P of B is equal to 0.05. Let P of B given A, the people prescribed painkillers are addicts, is 8%. Out of all people prescribed pain pills, 8% are addicts. So what we have to calculate? What is the probability that they will be prescribed pain pills? So that is probability of prescribing narcotic painkiller, given that the person is narcotic addict, is probability of B given A multiplied by probability of A divided by probability of B, which is equal to 0.16.